Coming up on this episode of Triangulation, Jason Innes from KinderLab Robotics.
Netcasts you love.
From people you trust.
This is Twit.
This is Triangulation, episode 377, recorded December 17th for December 21st, 2018. KinderLab Robotics. This episode of Triangulation is brought to you by Rocket Mortgage by Quicken Loans, introducing Rate Shield Approval. If you're in the market to buy a home, Rate Shield Approval locks up your rate for up to 90 days while you shop. It's a real game changer. You can learn more and get started at rocketmortgage.com/triangulation. Hello and welcome to Triangulation. This is the show where we sit down and chat with people who are doing all different kinds of things in the world of technology. Sometimes people write an amazing book. Sometimes people, influence a whole generation of children to get into coding. You know, no big deal. That is the case with today. I'm Jason Howell. I love doing this show because I get to talk to people just touching on all facets of technology, and education is obviously, it's so important. I feel like right now we're seeing so much evolution around kind of the approaches to getting children excited about computer science, one, and also learning, beyond just computers and how to use them, learning how to create for them. It's a whole new art world. It's artistic endeavor. If you want to call it art, it certainly can be art. It can be so much more. So today we're going to be talking with Jason Innes from KinderLab Robotics. Jason is the manager of curriculum development and teacher training at KinderLab. How you doing, Jason?
I'm doing well. Thank you, Jason. It's great to be here.
We know that for sure that today it's going to be really easy for us to get our names right. So we've got that going for us.
Definitely.
It's really great to have you here today, hopping on to talk about this technology topic. And I have to say, this interview kind of came out of probably like a month and a half ago. I kind of ran across something online, and it was all about this toy called Kibo. That it's like a little robot that kids can play around with. Talking 4 to 7 year old children use this robot to learn coding concepts, and I was just captured by where we are right now and what is enabled. Because I know when I was this age, like this would be the stuff of dreams. Like our toys were toys, but like we weren't creating robots, or at least I was creating robots maybe out of like toilet paper rolls, empty toilet paper rolls, and they didn't really do anything. Now kids can actually create moving, just really creative robots. It's an amazing time to be involved in education, I have to imagine.
Definitely, yeah, and I'm glad that you framed it that way with reference to the sort of imaginative experiences that we had kind of creating with art materials, with craft materials, with cardboard boxes and styrofoam, because that spirit of kind of bringing our imaginations to the experience is really the foundation of, it's the foundation of the design behind Kibo, and of the reason why we're so passionate at KinderLab about giving kids kind of creative, empowering opportunities to express themselves with technology. But it's also at the foundation of kind of the reasons that we want to bring technology into education and into schools. We know that children, especially young children, learn best when they're engaged in creative exercises, when they're exploring their own interests, when they're having hands-on opportunities to engage with technology, with materials, when they have opportunities to move and to collaborate. And so Kibo, which is a robotic coding platform designed for the early education environment, is really designed to sort of tap into all of these aspects of child development that we know are so important at this age and really throughout education.
Yeah, and it's really something to kind of bring your own child. Like I have 5 and 7 year old daughters, and to bring Well, you guys were gracious enough to send me to play around with this huge, basically toy, kit, a Kibo kit that has all the different components, and bring this kit home and set it down, for my 5-year-old. And just like the very first day that I brought this home, I just kind of opened up the box and I was like, "Hey, babe, look, we've got a robot. Why don't you, learn how to build it?" And it was just really cool to see her, like, almost instinctively pull these things out piece by piece and know with very little amount of time where things go. Oh, this fits this way versus that. What does this do? Oh, that looks like an ear. Oh, that, this, oh, that's a light bulb. And, she was figuring it out over time and then discovering the blocks. I mean, the whole kit is just perfect for children in this age category. And I feel like when you're talking about some of these advanced concepts around coding especially, we don't think of that age group as being kind of the ripe, the ground, the fertile ground for understanding these concepts. Yet that's entirely what Kibo, and I think by a larger degree what KinderLab is all about.
Definitely. Yeah. And thank you for sharing Kibo with your daughter. That was really great to see that video. Watching kids interact with Kibo is something that I just never get enough of. But you're right to point to a few aspects there. I mean, the robot is designed to be assembled by kids, which is it's an important part of the design of the robot for us. When children engage with technology in society, in the modern world, usually the technology is presented to them as kind of a finished product. Mm-hmm. If you think of an iPad or an iPhone, I mean, they're amazing technologies, but they are what they are. They're a sort of closed system, and they're almost designed to feel magical, to feel like they work through principles that no mere mortal could ever divine. Whereas Kibo, it was important to us to design a tool that doesn't just support coding education, although that's important and we can talk about that, but we want children to engage with the physical object that is Kibo in a way that kind of brings them into the experience as engineers themselves. So like the body of the robot has a clear bottom so that the children can see through the bottom to the circuit boards, the wires, the batteries, the sockets that the motors connect to. The parts are all individual, so the children attach the motors, they attach the different sensors and output devices, not just sort of the one right way, but in whatever combination they need in order to create the robot that they're trying to create. So we've taken the idea of kind of engineering and building a robot and made it accessible for children of this age, the sort of 4 to 7 age group that was the focus of the research behind Kibo, given them the control over the parts, but simplified it in order to make it approachable and have that kind of immediacy that you just mentioned your daughter experienced.
Oh yeah, I mean, immediacy is the perfect word. I mean, there was very little ramp up, and a little bit of talking through the blocks, of course. We'll get into that in a little bit as far as what the blocks are. That's really kind of at the core. That's the fundamentals of coding and the order of a piece of code and the instructions and all that. But I'm curious, as far as you are concerned, so you've been working full-time with KinderLab for not a huge amount of time, probably a couple of years. You've been exposed to it prior to that. I'm just kind of curious on your background as a kid. Did you ever think that you'd be this connected to education and technology? Were these things that you were very close to when you were this age, or maybe a little bit older?
I would say I was very connected on the technology side as a kid. When I was 6 years old, I think, we got an Apple II in the house. Mm-hmm. Which was the first experience that I had with kind of a creative technology. And the thing about computers then, there were games, there were software that you could buy, but right out of the box, when you would turn the Apple II on, it didn't actually do anything. But it would boot right into an environment that allowed you to create programs. And so that was my kind of first experience with technology, was with these tools that invited you to create for the platform. There was this sort of back and forth almost. As a user of these technologies, you are also inherently a creator on the platform, because without writing software, the computers didn't really do as much.
Right.
And I maintained sort of an interest in technology throughout my education. I actually studied virtual reality in college, but it was a little bit before its time in terms of being able to jump right into a career in that field. But I did end up working at an educational publisher, working on a networked collaborative writing software for the education market. So my interest has always been kind of at the intersection of technology, creativity, communication, and education. And when my own kids came along, actually, I started trying to find experiences, tools, opportunities for them to have the same kind of feeling about technology that I did, which was that these tools exist to help us create, to help us express ourselves. But there weren't the educational software at the time. My kids were born in just after the turn of 2003 and 2006, and there weren't that many tools that I felt were available for them that were sort of putting that creative experience first in the educational software environment. Mm-hmm. So I started looking around for sort of the best tools like that to offer to them, and that led me to find Scratch, which is a kids programming language that was developed at MIT at the Media Lab. It's a wonderful tool, and it's become the basis of really all sort of upper elementary and middle school coding tools. Google has created a coding environment called Blockly that's kind of inspired by Scratch, and which has become the foundation of a lot of coding experiences for older kids, like upper elementary into middle school. But I also was personally very interested in how can we start these kinds of experiences, create this kind of attitude toward technology that's inherently kind of appreciating the creativity, the creative possibilities, and the joy of creating with code, with technology, but offer those experiences to even younger kids. And that was how I found the work of Dr. Marina Bears, who had been at the Media Lab and collaborated with them on Scratch Junior, which is a coding environment based on the iPad for kids younger than the average Scratch user, so for kids more like 4 to 8. At the same time that she was developing Scratch Junior, her team at Tufts was also working on what would become Kibo, which is a kind of translation of these early childhood coding opportunities into kind of a physical robotic product.
Yeah, and of course, Dr. Marina Bears, I mean, you know, her background, as you say, ultimately led to everything that's happening here with KinderLabs. And one thing that really kind of stands out to me that she focuses a lot in, you know, she has a TED Talk that's really wonderful. Everybody should definitely check that out. Is this idea of playpens versus playgrounds? Maybe talk a little bit about that, because I really feel like that at its core is really what this is all about. Not keeping children kind of, you know, confined into this area of limited exploration, but really just kind of opening it up and saying, cool, go to town and learn what you learn.
Yeah, definitely. The idea of sort of the playground versus playpen is one of the foundations of Dr. Bears' research. She has a number of books that she's written, and it was actually through some of her writings that I sort of discovered her and her work and came to join KinderLab. But the idea that she sort of elaborates in her books and in her TED Talk, as you mentioned, is this idea of imagining the different experiences that children have in the playpen versus the playground. And both of these environments are environments that are designed by adults for the benefit of children in one way or another. But the goals of those two different environments are very different. Like the playpen environment, really honestly, the main rationale for a playpen is kind of to control the child and limit their movement so that the adult can go get something done. But we usually include some kind of sort of educational toy. Maybe there's something in the playpen that the child can interact with, but whatever's there is what we've chosen to place there. And the limits that we've placed on the child sort of define the range of experiences that the child can have. Versus the playground. A playground environment, it's also designed by adults with the educational and developmental needs of children in mind. But the kinds of experiences that kids can have on a playground are inherently more open-ended. They're more based on the child's exploration. They involve the imagination more strongly as kids kind of interact and turn the playground into a pirate ship or a castle or whatever. And also the experiences on the playground are more often social. So children are engaging with each other. They're collaborating. They're inventing games. They're inventing the rules for those games. They're negotiating, who's sort of playing according to the rules and who's not. And they're expressing themselves to each other. And these different kinds of environments really can serve as metaphors for different kinds of experiences that kids can have with technology. And so our goal, maybe an app that's designed to drill children on math skills, that can be wrapped in sort of a coding that makes it a fun experience. It can be motivating. There can be sort of feedback that keeps the kid going, but it's ultimately a playpen style experience. The range of possibilities are limited by the explicit goals set by the designers. So what we should be trying to do is create technologies that give kids more of a playground experience where we haven't really decided for them the full parameters of what's possible. Instead, we give them tools that they can use to create, to explore their interests, and to express themselves, and also to engage with each other in a social way.
That's fantastic. I love that. How are schools in being receptive to this kind of methodology? Of course, this is a large part of what you do for KinderLab is you're working on formulating a curriculum around this and working with teachers. Is it a little overwhelming for them to a certain degree to kind of hand the keys over a little bit and be like, all right, here's an unrestricted playground, instead of here's this thing we want you to work on? It definitely takes a little bit of a mind shift.
It can. I think, it's amazing to be able to work with teachers around implementing Kibo. It's every conversation I have with a teacher sort of brings a different perspective, and I learn something working with teachers in talking to them about how they implement Kibo. I think one thing that's really special about Kibo is because it's designed for the early childhood classroom. That is for children who are in pre-K to second grade in sort of American grades. These teachers are very much aware of the general educational philosophies that really support Kibo as well. So, for example, constructivism, which is a educational theory, really a learning theory that says that children learn best when they're given the opportunity to, through their own experiences, to discover knowledge for themselves, as if they were sort of discovering these things for the first time. And that's one of the strongest kind of intellectual currents in early childhood education. And it's one that a lot of teachers, even if they don't see themselves as sort of technology friendly, they're teaching this way in their early childhood classrooms. They see themselves as mentors preparing educational experiences for their students to go through and to create their own understanding and their own knowledge through these prepared experiences. So part of my task is helping teachers see that we can introduce technological tools, coding tools, robotics, to support the same kinds of experiences that teachers are already looking to create and support for their students. So there's definitely a population of teachers who feel like, I never learned to code, and this feels sort of new and strange to me. But when we can help teachers see that kids can express with code in the same way that we have them express with writing or with painting or with imagination play. If we can get teachers to understand that coding and robotics support the same kinds of sort of integrated expressive play that involves collaboration, it involves critical thinking, it involves planning, revising, and testing. All of these kinds of behaviors are the same sort of skills and behaviors that we want to encourage with young kids anyway. Giving them technological tools to do it just gives them a new way to sort of express themselves and explore their interests.
I love watching video of these kids creating things and watching them and beyond that, watching Kibo kind of carry out their program. And like even my daughter did it. If you saw the video, once it starts doing its thing, it's like they celebrate. It's like, wow, that's amazing. I did that. I love it. And that's the beauty of Kibo and what you guys are doing. Let's take a quick break. We're going to take a break and thank the sponsor of this episode. Then we'll get back and we'll talk about some specifics around Kibo, kind of some of the challenges that you've seen in getting, maybe introducing this to children. Do they embrace it immediately? Some children, might have a more, I don't know, there's levels of abstraction, and I'm sure this works for some. Maybe it's a little bit more difficult for others, but we'll get into more about Kibo and talk with Jason a little bit more. But first, let's take a minute and thank the sponsor of this episode, and that is Rocket Mortgage by Quicken Loans. If you're thinking about buying a home, you know that interest rates, they're kind of all over the map, or at least they're just rising right now. Little by little, that percentage rate keeps increasing. And so you might be thinking, I want to buy a home. I don't know if now's the right time. Things are changing. It's a little uncertain. Maybe that gives you a little bit of anxiety. It can be a stressful experience. Well, our friends at Quicken Loans are doing something about that. It's called the Power Buying Process, and it's super simple. Just a couple of steps. Step one, you answer a few simple questions, and they'll check your credit for pre-qualified approval. So you'll get that pre-qualified approval. You can kind of start looking around and seeing what's out there. Step two, Quicken Loans will verify your income, your assets, and your credit in less than 24 hours, so it doesn't take very long to give you a verified approval. And that gives you the strength of a cash buyer. So once you find something, you can be like, all right, let's put in our offer. We're going to go for that home. Now, step three, once you're verified, you qualify for their all-new exclusive Rate Shield approval, which means they're going to lock up your rate for up to 90 days while you shop. So you can find just the right place, whatever the rate happens to be at that point, it's going to be locked in place. And the best part is if the rates happen to go up within those 90 days, your rate is going to stay locked into the same place that it was when you locked it in the beginning. If the rates happen to go down, don't worry, your rate's also going to drop. So either way, you win. It's awesome thinking. No surprise from America's largest mortgage lender. So to get started, go to rocketmortgage.com/triangulation. Rate Shield approval is only valid on certain 30-year purchase transactions. Additional conditions or exclusions may apply based on Quicken Loans data in comparison to public data records. Equal housing lender, licensed in all 50 states. NMLS, consumeraccess.org, number 3030. That's rocketmortgage.com/triangulation. And we thank Rocket Mortgage by Quicken Loans for their support. So I'm not going to unbox the whole thing here because you guys you sent me the mega kit, I have to imagine. This thing is chock full of stuff. It's just a lot of fun, very tactile. Everything comes out. This is kind of the base of the actual Kibo robot. And then everything, as you see here, just gets plugged in really easily on top like this. I can put in this component. Things are shaped so that kids know exactly how it pops into place. This is the ear, which my daughter thought was hilarious when she realized it looked exactly like an ear. So, you guys have done a lot of thinking around how to create something that is durable, because this is not a cheap feeling toy. Like a 5-year-old or even a 4-year-old is going to play around with this. Things are going to fall all over the place, but it's not going to break. It's really tough. I don't know. Talk a little bit about kind of the expandability aspect and kind of the creativity that goes into building. I'm sure you have forms that are built very standardly speaking. Kids pop an ear on there because it can hear things and it executes on it. But then I'm sure some kids come up with some really creative stuff. How does that play out?
Definitely, definitely. So the parts of the robot, I sort of when we talked earlier about the reason we made all the parts separate is we want the kids to understand the function of each of the separate parts. So, for example, your daughter was interested in how the sound sensor looks like an ear, and that's very intentional. With kindergarten in particular, a very common thing that kids are learning about at that age is our human senses, the five senses, the way animals and people kind of experience the world. So we wanted to take advantage of that by giving Kibo's senses a sort of familiar shape so that kids could connect this knowledge that they're learning about themselves and about animals to the capabilities of the robot. And that extends kind of to all of the parts of the robot. So the children assemble the robot and attach the parts based on the functions that they want the robot to have, but then also what they want to turn the robot into. So building onto the robot is an important part of using Kibo and also of integrating it into the curriculum. So the robot, the package that you have actually comes with a couple of different platforms that the kids can use to build onto with just really familiar classroom craft materials like cardboard boxes, construction paper, pipe cleaners. We want them to take these materials that they're used to using, again, in an expressive, open-ended way, and give them the ability to transform the robot with those same kinds of materials. So, for example, one of our curricula is based on the idea of creating a robot dancer. So kids might research a dance or a culture or music from a particular part of the world, learn about the costumes that people wear during the festivals when that music is played, and then use construction paper, googly eyes, pipe cleaners, tissue paper to turn their robot into a dancer who wears that sort of costume, and then create a program to have their robot dance along to the music. So this way we're incorporating robotics and coding and engineering and trial and error and revision, but we're incorporating it into what really feels like essentially a social studies unit, into an opportunity where kids are learning about music and movement, they're dancing themselves. So these kinds of integrated experiences are possible with a tool that's designed to be kind of expanded and built onto. And I thought it would be helpful to just sort of touch on the coding method, which you did yourself in a little bit there in describing your daughter's experience with it. So the sort of flip side or the counterpoint of robotics is that a robot is a special kind of machine that is programmed by people. So we, the programmers, the students, tell the robot what we want it to do using coding. And part of the important sort of design goals behind Kibo was to create an entirely screen-free experience of coding for children. Now the value of sort of screen-free time is well known, I think, by parents and teachers just in general for its own sake. But programming in a screen-free way is especially relevant for the early childhood classroom because at this age, children really respond best to concrete physical objects and to manipulatives that allow them to learn in a concrete way. So coding, which is inherently a pretty abstract thing, is made even more abstract when kids do all of the work on screens. So instead, Kibo is programmed using a collection of wooden blocks where each wooden block represents one function for the robot to perform. So the kids create sequences of these wooden blocks, and then they use a scanner that's built into the front of each robot to read the barcodes on each block. So they load their whole sequence into the robot's memory and then push a button for the robot to act out the program. So they never need to use any screen, no iPad app or computer. They're engaging with coding, and it's a full-fledged coding language that Kibo uses, but it's entirely represented in these physical, tangible objects. And that helps kids, especially on the younger end of our age range, really connect with these concepts for the first time.
Yeah, and I love the fact that like working with the blocks is so super intuitive with the scanner. Both of my kids loved kind of the scanning process, and at some point they kind of made the connection that a program or a sequence doesn't have to be just each block once. You could use the scanner to keep going on the same thing to make it go further instead of just one kind of programmed, movement forward or whatever. And that I think is where that's where you start to see the light bulb go off, where it moves beyond this like puzzle that they're putting together and into a piece of art that they're creating, where they're like, oh, wait a minute. I don't have to just be locked into this sequence. I could decide that I want it to play the song 3 times instead of 2, or, and it gets even more complicated from there because there's like a repeat block or an if, you start to kind of go into the direction of if then sort of options. So it really does cover the gamut. One thing I know, because you and I talked a little bit prior to this this interview to kind of discuss some of the angles of this, and one thing that I thought was really interesting that you brought up was this idea that when we're talking about something like Kibo and how it's good for teaching the language of coding, you mentioned that it's not necessarily always because we want to create a generation of coders. And you compared it to everyone reading or writing doesn't necessarily mean that we're creating authors or we're creating novelists or whatever. Maybe talk a little bit about that, because I think that's really important. This is another language that whether we're working in this field or not, we should be aware of.
Yeah, definitely. Thank you for bringing that up. And that's that metaphor that you described is actually something that comes from one of Dr. Bears's books, and it was one of her first books that I read that sort of drew me to the work she was doing with Kibo and KinderLab, designing digital experiences for positive youth development. And I think just that title says so much, which is that the sort of framework of the research and the thinking behind Kibo, behind Scratch Junior, behind the work that her lab is doing and that KinderLab is doing is really as much about developing the assets that children have, things like creativity, their confidence, their competence, part of creating these sort of playground experiences with technology is to help children develop these abilities that we're trying to develop in them as educators, regardless of sort of the technological component. And she makes that wonderful point that literacy, learning to read and write, is something, a sort of skill that we take for granted as a goal of the educational system. But we don't teach children to read and write just to give them the functional ability to do like a career that involves reading and writing, like journalism. We want children to be able to read and write so that they can, read all of the amazing literature that's a part of our cultural heritage. We teach them to write so that they can write a love poem or a shopping list. These are examples that she gives from her book, that we teach children these skills in order to allow them to express themselves and to participate in our civilization, really. And we can see coding in the same way, that it's sort of a buzzword these days that coding is a new literacy. But if we follow that all the way to its conclusion, the same things should apply. We don't need to teach children to code just because we want to encourage them to be coders or to be programmers when they grow up. We want to teach them to code because creating with these technological tools and being able to see themselves as creators with technology is an important sort of lesson or self-conception that we want to instill in kids as they grow up. So we're giving them these skills so that they can express themselves, so that they can investigate their interests, so that they can explore sort of new areas that will be coming up in the next century, not just to create a new generation of engineers and coders.
Right, and I mean, not only that, the role of technology in our lives now compared to even where it was 20 years ago is just so much more expansive. Of course, the more we can do to, help to teach those concepts, the better for children, because they're going to need that knowledge in ways that maybe we don't even understand at this point. 20 years from now, that's only going to expand out further, and who knows how much more important it's going to be then.
Absolutely. And actually, educational systems across the country, states and the federal government are definitely recognizing that. And more states are exploring different ways to bring computer science standards, coding standards, digital literacy standards into education. And so children are going to be exposed to these kinds of skills more and more throughout the K-12 educational system. But I think that's all the more reason why we should sort of, starting with the youngest kids, we should give them experiences during these earliest years that help them position themselves as creators with these tools. We don't want kids to necessarily see coding as something that's just another box to check off in education. It's like we want the kids to absorb that message that they can express themselves with these tools, as well as just sort of solve problems or write computer programs. And Kibo is the sort of tool that allows sort of teachers to see that computer science, coding, problem solving, and creative technology use can be integrated across sort of the whole curriculum and not just sort of siloed off in computer science hour or the computer studio.
Sure. Now, what would you say are some of the challenges here? Because I know that technology is empowering. It can also be distracting depending on how it's implemented. You talked a little bit earlier about screens, and some people, there's definitely a movement right now. Sometimes I find myself in there, and I hate that I do, because as a kid, I loved my computer. But sometimes I feel like I get pulled into that realm of like, too much screen time. I've got to pull them more into the real tangible world. And really, it just ends up being this feeling of like I'm distracting them by letting them distract themselves instead of like enriching themselves by my parental definition, staring at a screen, watching something, versus being active with something like Kibo that feels very tangible and everything. Is that a hurdle that we're trying to figure out right now in the educational space?
Definitely. I mean, I think that's a really common concern. And there have been studies and a lot of different sort of conflicting recommendations about screen time sort of on its own as a positive or negative for children. But I think that with all of these technologies, really with any tool, the most important aspects are the quality of the experience that the child is having with the technological tool, whether it's a screen-based one or not. So a creative experience, an experience that engages the child's imagination and that allows the child the freedom to sort of pursue their own interests. Those experiences are going to be developmentally appropriate, whether they're on a screen or not. And then the other component to consider is the quality of your engagement. I mean, you're as a parent, you're thinking about the impact that these experiences are having on your child. That's a great opportunity to engage your child in a conversation about what they experienced, for example, when they were using an app or watching a show. So even screen time that we see as kind of passive can be an opportunity to engage your child and participate in that experience with them. And that will also kind of convert that experience into one that's sort of a developmental growth opportunity. I guess we, as a design principle behind Kibo, I can definitely see where you're coming from. And that's one of the reasons that Kibo in particular was designed to be screen-free. But the lab at Tufts that Dr. Bears runs, she's by the way, she's the chair of the Elliott Pearson Early Childhood Development School at Tufts, but she's also an adjunct professor in computer science there. So she's very much at that intersection of how can we use technological tools to support the positive development of children. And so although her research led to Kibo, which is a totally screen-free tool, she and her researchers are also responsible for developing Scratch Junior, as I mentioned earlier, which is an iPad-based coding and storytelling environment. So we're not biased, on day one against screen-based experiences. The important thing is, are they sort of playground-style experiences that let a child express, explore, and grow in the same way that a playground does?
Yeah, and I mean, Scratch Junior, that the talk about a creative playground, as you say. I mean, there's all different ways that kids can create and then share, and it's just such a cool kind of counterpoint to Kibo. One kind of question or thought that I had is, as both of these kind of separate things are developed out further, like, has there been any thought about how to bridge between the two? How does a child work with Kibo and understand the concepts there, and then translate that experience into Scratch Junior? Or maybe there ends up being some sort of like an actual technological kind of bridge between them at some point down the line. Who knows? But I don't know. What do you think about that?
Yeah, definitely. I mean, we really see Kibo as occupying a sort of position within a whole pathway of kids' experiences with positive creative technology. So Kibo is designed for those youngest kids, like 4 to 7. But after using Kibo, kids could transition into Scratch Junior and Scratch and the whole world of sort of screen-based coding tools for kids. They could transition into other great robotics tools. There's a whole range of other programmable robotic products that are really designed for like older kids. They use screen-based programming tools. Lego Mindstorms is probably the sort of classic educational robotics product, and it was actually developed by Lego in collaboration with another MIT professor, Seymour Papert, who was one of Marina Bears' mentors when she was at MIT. So there's a strong connection between all of these different educational robotics tools that are seeking to support kind of creative engagement. But the that sort of pathway that kids can follow, I think it's starting with something like Kibo is wonderful because of the physicality of it all, the idea of kids programming with these physical, tangible objects, but then seeing the effects of their program on a tangible physical robot is one of the great advantages of robotics with early childhood, because it's so much more engaging when kids can make like a real object move around versus just sort of a character on the screen. But I share your sort of like geeky fantasy as well of like a direct connection between what kids are doing with Kibo and Scratch Junior. And actually there has been work on a sort of prototype module that would allow kids to use Scratch Junior to create a program that would transmit to Kibo, but it's too early to promise anything on the commercial front. But I completely agree with you. It would be a natural thing to help kids sort of take that next step into screen-based coding environments.
That's amazing. I love the idea of that. Create something in Scratch Junior, flash it over to a block with a micro SD card slot in it or something with a code on it, and go to town. You could go a lot of directions with that. Obviously, a huge part of what you're doing is you're creating curriculum around this. You're working with schools to kind of introduce these concepts, I imagine. Like, how do you do that? How do you construct a curriculum around Kibo, and how does that tap into the progression of these concepts throughout these early years in school?
Mm-hmm. Yeah, thanks. Right. So my role at KinderLab is as the manager of training and of teacher training and of curriculum development. And I would say there's sort of two aspects to how we develop curriculum for Kibo. One is, like I mentioned, a lot of states are beginning to adopt standards around computer science education. So starting to define specific goals for what children should understand and what kinds of experiences they should have at different grade levels. Mm-hmm. And we're collaborating in those efforts. We're working with industry groups that are helping states to define those standards. And so we're developing curriculum that is aligned with those evolving standards. So there are just certain computer science concepts like sequencing, how to design algorithms, which are kind of stepwise solutions to problems, how we want to get kids thinking about like the engineering design process, how we want kids understanding more sophisticated coding concepts like repeat loops and conditionals, as you mentioned. So we have curriculum that is sort of our core curriculum that steps kids through these kind of fundamental computer science content. But the other side of that is it's important in early childhood education and in early elementary education, the experiences that kids have, as much as possible, be kind of contextualized and integrated into the kinds of daily experiences that they're having, into the subjects that they're studying in their classroom work. And so we strive to always connect our curricula to these subjects that we know that children are studying in preschool and kindergarten and first and second grade. So we have curricula that are based on exploring mathematics and measurement concepts using code. We have curricula like the one that I mentioned with the dance exploration, where kids are learning about another culture, they're learning about music, maybe they're collaborating with the music teacher to perform the music themselves, to do the dances. And just as a natural part of this, they're also just programming their robot dancer to dance along with them. So it's a natural incorporation of these technological concepts, but in a way that fits into the kind of expressive work and cross-curricular work that the kids are doing in the classroom. So that's really the focus of our curriculum development, is working with teachers to understand and to get ideas about different ways that they can incorporate these kinds of experiences into the work that they're doing on a sort of day-to-day basis. We had this one of the most recent trainings that I went to. I had this. It was in Miami-Dade School District, and one of the teachers there shared an amazing idea that she had, which was their school is welcoming a whole group of new students into the school, and she had the idea of having her current students create a Kibo program where they created a map of their school, and then they dressed up they treated their Kibo as a new visitor to the school, someone who was coming into the school, who navigated around the map of the school that they created with code. But the students in the class greeted the robot and practiced how they would talk to and welcome their new classmates once they arrived. So they were using the robot to sort of engage in this social emotional development and role play about what it was going to feel like to welcome new students to their community. And I thought that was so beautiful, because it's not sort of the first thing that crosses your mind when you think, what does computer science education look like? But for teachers who use Kibo, that's exactly what it looks like.
That's amazing. I love that story. That's so cool. And what's interesting to me about that, even beyond, is this idea that we are so early, just in robotics in general. Like, I feel like, when I was a kid looking at robotics, it was very much the Jetsons, style future or whatever. And now you've got actual, in the classroom versions of these robots, and, where does that lead to 20, 30 years from now? And these children who are engaging and basically creating robots to socialize with, or like you say, role-playing in these particular scenarios, those same kids 30 years from now, they're going to have a completely different interpretation of what an actual, living a life that involves robots, what that actually means. It's going to mean something totally different. And part of that is because they learn from a very young age that robots can play a respectable kind of social, element in their life at a very young age, and they get close to programming them as well and creating their behaviors.
Yeah, I think I agree with what you're saying, and I think also the other way to spin that, though, is that robotics provide the children with a way to explore their own emotions through the way they kind of interact with the robot. So, and I guess the other lesson that I imagine, in 20 years, kids who've had this experience with Kibo, one of the most important lessons they can take away from this about robotics is that robots do what they do because humans programmed them to do that. And what we want to do is give kids that confidence that we're the creators in this kind of relationship between ourselves and our technology, and we take an active hand in creating the technology, creating with the technology, and in creating the society that includes this technology. So I think that's probably one of the most fundamental lessons I hope kids sort of get in the back of their mind with this experience is robots do what they do because I created this program to make them do it.
Right. Now, kind of touching on that, though, kind of expanding that out a little bit, is this whole, we're also kind of in the midst of an AI revolution, so to speak. Everywhere you turn, it seems like if technology is the topic, there's always an addition to that, which is, well, what about the AI component, or what about artificial intelligence? So how does that interplay with children and their development and their awareness of robots? Because as you say, like right now, a large part of the understanding is the robot does this because a human programmed it that way. There are certain levels of AI and neural networks that a human didn't necessarily program it. It just did that itself. So that's going to shape how our children view and respect and program robots going forward, right?
Definitely. Yeah. And that's getting into like a whole sort of aspect of future development of technology that like, I don't think Kibo in particular will ever achieve sentience. But it's something to think about with kids' relationships toward technology for sure. I mean, I think we're the experience that kids have of engaging with technology from the position of themselves being creators. Again, I just kind of come back to the most important and age-appropriate lesson that we can take from this. I mean, kids are engaging, they go home and they'll have conversations with Siri that are
absolutely,
like, to my mind, when I was like programming my Apple II as like a 6-7-year-old, the idea that I could have that kind of conversation with a device that you can carry around in your pocket would have been inconceivable, and so kids are growing up with this idea. I mean, Siri is a long way from, an autonomous AI, and yet kids can already have conversations with it that have a clear, like, emotional content for them. And that's, I honestly have no better guess about where that's going to go from an educational standpoint than anyone. But I come back to the idea that giving kids fundamental experiences that position them as creators with technology is the best way for them to kind of keep an even keel and keep a perspective as society goes through the changes that it is sure to go through in the next few decades.
Yeah, I mean, I completely agree with you. We've got Google Home through the house, and I mean, even a year ago, my 5-year-old, she was 4 years old, and she knew then the syntax. She knew the language of technology, how to talk to it to get it to play a song, or how to find the definition of something. At 4 years old, she knows how to surf the internet because the technology allows for it. That's the crazy place that we are now, and how empowered that information, the availability of that information is for our children. What a crazy time. One question I wanted to ask you about, because it's definitely close to my heart in our home, is this idea of technology and creativity around programs like Minecraft. There's another one called Roblox that my 8-year-old daughter is way into Roblox right now. What do you think about platforms like that? Because they really do kind of seem to be largely a lot of what you're talking about anyways. It's entertainment, yes. It's playing, yes. But it's also kind of a playground in the sense that children can create their own levels. They can really create things from the ground up. Are there lessons to be had there? What are your thoughts on solutions like that?
Definitely. I think those are great examples of playground technologies for older kids. But they give the same kind of experience where kids can kind of imagine something. I'm thinking of sort of essentially the creative mode of these kinds of games, right. Where kids can create something. They can, just by projecting their imagination onto it, they're having the same kind of experiences building in these environments that you can have building with, like, building a fort with your sofa cushions. It doesn't involve the physical movement, which is a very important component of kind of traditional imagination play in that way. But the mental side of what kids can engage with in something like the creative mode of Minecraft is, I think, just as fundamentally creative. I think there's also a really exciting component to when kids create, using Roblox, for example, where there's a coding aspect to the environment, where kids are coding like behaviors and they're coding rules. They're even creating like fully functional games with tools like Roblox, or again with something like Scratch Junior. There's a sort of educational theory term called perspective taking, which is the ability of a child to imagine the experience of someone else. And when kids, this is actually, I'm again sort of cribbing from Dr. Bears's work, but when kids create a game or a story using Roblox, or when they create like a house or castle that they want someone else to explore in Minecraft, or when they create with Scratch Junior, they're sort of required to think about what the experience will be like from the perspective of their user. Which is something that, you know, professional software developers have to think about all the time. But from a child development point of view, it's this fundamental experience of empathy development. So when a kid is creating like their house in Minecraft, and they're excited to bring someone else in and show them the house and say, you know, this is how I go in, and then look at how I decorated the ceiling, and where would you want to go from here? Which door do you want to take? They're taking the perspective of another child when they imagine sort of the viewer of their creation. And that's just an example of the kind of sort of social and cognitive development that kids can engage with tools like this. So I think that those tools can be very positive, and it's just a matter of introducing them at a time when a child is sort of ready for that type of interface, and then sort of prompting them to think about and to have these kinds of creative experiences in the tool rather than purely kind of consumer-based experiences.
Awesome. I mean, it's such a cool time right now. You know, there's a lot going on in the field of kind of emerging STEM toy, STEM integrated, and in the case of Kibo, STEAM, which, you know, adds the art into the whole deal. You know, STEM and STEAM with toys and technology, all of it coming together. We're seeing a lot of solutions, a lot of products that are coming out, and I think doing a really good job of bridging this and helping kids have the fun that they so desire, but also be inspired by that to learn, and really in the end learn these concepts that are going to serve them very well as they grow older in this technology, you know, technologically advanced world that we're living in. If people are watching this or listening and they're like, man, you know, I would love to get a Kibo curriculum integrated into my school, or my, you know, this would be great for my child's kindergarten class or whatever. Like, what do you recommend people do if they really want to kind of get their schools looking into this, if they aren't already?
Absolutely. Well, we are, although our company was created out of the research that was done at Tufts by Dr. Bears and her group there, we are a commercial company. We were created with the support of an NSF grant that was designed to commercialize Dr. Bears's work. So the express purpose of our company is to take this essentially research project and manufacture it in a way that makes it affordable and cost effective both for schools and for individual families. So our website, which is KinderLabRobotics.com, through there you can get access to a shop that allows you to sort of buy individual kits for yourself, or you can contact us. You can contact me if you're interested in the sort of educational and curriculum side of integrating this kind of robotics into your school, or you can contact our customer service and sales folks if you're interested in finding out more about how to bring the robot into your school. We've had individual teachers, you know, buy one with the support of a donor's choice grant, all the way up to entire school systems that have implemented Kibo at the district level. So we're open to a wide range of different models, and I'm also just always interested in talking to teachers about their goals and recommending solutions, including Kibo or otherwise. So anyone can reach out to us via our website. I'd love to talk.
Awesome. Jason Ennis, Manager of Curriculum Development and Teacher Training at KinderLab Robotics. It's been awesome talking with you, and thank you so much for sending the kit my way so I could introduce my children to it. They had an absolute blast with it. We didn't even get a chance to talk about the or show the video of the launcher, which is like a new attachment. Once I like popped this on there, because it was in a bag, so they didn't notice it at first. I mean, I think they spent a good half hour launching ping pong balls all around the room. They thought it was so hilarious.
Definitely, that's a dangerous one in the classroom.
Oh, here it is. I think it's about to work. She may get in the way and pop. Yep, that's a good one. Love it.
See, that gives the youngest kids hands-on experience with physics.
Absolutely. Yeah, my 5-year-old daughter was trying to catch the balls every time they were shot, so it became a game. So anyways, Jason, such a pleasure talking with you. Thank you, and keep up the wonderful work. I love what you guys are doing with Kibo. Thank you
so much. Thank you for having me on, and thanks for playing with Kibo with your daughters. I really appreciate that.
All right. Take care. We will talk to you soon. We do this show, Triangulation, usually we do it every Friday. This is actually a pre-record because we got the holidays coming up. But normally, when everything is running normally, these shows happen every Friday, and you can catch it at twit.tv/live, Fridays at 6 p.m. Eastern, 3 p.m. Pacific, 2300 UTC. If you're not around to catch it live, then you can just go to twit.tv/TRI or twit.tv/triangulation. There you're going to find all the episodes of this show. Tons and tons. I'm telling you, there's so many interviews with amazing people just like Jason talking about their specialty, their focus, their book, a number of awesome technology topics for you to dive into. You've got your work cut out for you for this holiday. If you want to catch up, you can do that. twit.tv/TRI. And I think that's about it. Thanks to Burke here for helping in the studio. Thanks to Carson, the producer of this show, and thanks to you for watching. We will see you next time on another episode of Triangulation. Bye, everybody.